Hello, 6th graders. We are now in section 8.4, which covers surface areas and volumes of similar solids. So I want you to look at this, and if you want to pause the video and write this down or do this yourself, you can. But let's fill this out because this is like an activity. Tell me what you see. So let's look at it. These are obviously all cylinders where the radius stays the same. So all I am doing is changing the height. Remember, a cylinder is pi r squared h for volume, and the surface area is 2 pi r squared plus 2 pi r h. Now let's say you went through and actually did all of this. You would get the surface area here as 4 pi, 6 pi, 8 pi, 10 pi, and what do you think the next one's going to be? Good, 12 pi. Now the volume here is going to be pi, 2 pi, 3 pi, 4 pi, and 5 pi. So can you look at this and tell me what happens here? Every time the surface area increased by 2 pi, the volume increased by pi. Now, if we want to know if these are proportional, I'll save you some time and just tell you that they're not. This is not proportional. And if you describe what changes here, the radius is the same. The height increases by 1. The surface area changes by 2 pi. The volume increases by pi. Now, they're not proportional. Here's why they're not proportional. The height actually goes up as well as the volume, but the radius stays the same. So because the radius stays the same, nothing else stays the same. These are not proportional. So A would be not proportional. Let's look at the next example. Do the same thing. Well, let me just tell you what the answers would be. Here we change the radius and the height. Now the surface area here is 4 pi, 16 pi, 36 pi, and you should see a pattern, 64 pi, and 100 pi. Here we have pi, 8 pi, 27 pi, cherry pie, just kidding, 64 pi, and 125 pi, even though that cherry pie does sound good. So now we have to see if we can see a proportional relationship. Now you're probably not going to see this, which is fine. But if I take the radius from, like, let's say the yellow, to the green, the radius doubles. If the radius doubled, what happened to the surface area? It multiplied by 4. If the radius tripled, this multiplied by 9. If the radius quadrupled, from 4 pi to 6 pi, it gets multiplied by 16. So we're squaring it each time. Times 2, we times this by 4, 2 squared. Times 3, this gets multiplied by 9. Times 4, this gets multiplied, the surface area, times 16. 1 to 5 multiplies by 5. 5 squared is 25, so 4 times 25 gives me 100. Volume is not squared, it's cubed. So if I go from 1 to 2, that times by 2. What's 2 cubed? It times by 8. Pi to 8 pi. From 1 to 3, I multiply this by 3. So from pi to 27 pi, you multiply by 3 cubed, which 3 to the third power is 27. From 1 to 4, we multiply by 4. 4 cubed, I multiply by 64. And it goes the same thing with 5. That's your relationship. So similar solids. Similar solids, vocab word, are solids that have the same shape and proportional corresponding dimensions. So let's show that in example 1. Example 1, I'm going to ask you which cylinder is proportional to cylinder A. So let's put up our problem. Which cylinder, so here's cylinder A, which cylinder, B or C, is similar to cylinder A? So we have to compare cylinder A to B and cylinder A to C. All right, so A and B. So we just checked the dimensions. The height, let's do height of A. Height of B, 4/3. Let's do radius of A, radius of B. So radius of A is 6 to 5. Are these two fractions proportional? No, not at all. So let's look at cylinder A and C. So this was not proportional. So let's just look at height. The ratio of A to C, the height would be 4 to 5. The radius of A to C, 6 to 7.5. Well, divided by 7.5 would simplify into 4/5. So 4/5 and 4/5, that is correct. So cylinders C and A are similar. Example 2. The cones are similar. Find the missing slant height L. We just set them up as a proportion. So we could do radius of X, cone X, which is 5, divided by radius of cone Y, which is 7, equals slant height of cone X is 13. Slant height of cone Y is L. We cross multiply. This is the cross products property. 5L multiplied by 13 and 7, which is 91. By the division property, I divide both sides by a 5. The slant height is 18 and 2/10 yards. Our key ideas. Linear measures. Linear measures are each of these. Length, width, height. Length, width, height. The radius and the height. The radius and the height. The radius. The surface area of similar solids. This is so important. If I said that solid A had a radius of A, and you doubled it, then the surface area is squared, so it actually quadruples. If solid A has a radius of 4, and then solid B has a radius of 12, what would you do from 4 to 12? That means the radius was multiplied by 3. That means the surface area would be multiplied by 3 squared, which would be 9. It's always squared. When two solids are similar, the ratio of their surface areas is equal to the square of the ratio of their corresponding linear measures. So in example 3, we want to know, what is the surface area of the pyramid? If pyramid A has a height of 6, so let's write that as a ratio, height of 6 to pyramid B's height, which is 10 feet. So this is A, this is B. Now, what is the surface area of pyramid A? We don't know it. Surface area of B is 600, but wait a minute. What do we have to do? Remember, we take the ratio and we square it. So that gives us 36/100 equals x divided by 600. I cross multiply. That gives me 100x equals 36 multiplied by 600. You take the product, you divide by 100, you're going to get 216. So that means the surface area of pyramid A is 216 square feet. Volume is the exact same thing, except we take the linear measures and we cube them because it's volume. So the ratio of their volumes is equal to the cube of the ratio of the corresponding sides. So here's another way to look at it. If I said this was 4 and this was 8, what happens here? It gets multiplied by 2. So the volume, if you're looking at what's going to happen to the volume is going to be multiplied by 2 to the third, which would be multiplied by 8. You're going to cube it. So if we look at our last example, example 4, what the dimensions of a touch tank at an aquarium are doubled. What is the volume of the new touch tank? Well, the first thing you could do is find the ratio of the sides. But the ratio of the sides is pretty easy because it's doubled. But you don't have anything. So, doubling them means that you could either do 1/2 or 2/1. I could say that it doubled. It went from 1 to 2. So, this is the old original volume. This is the new because it doubled. Well, since we're talking about cubed volume, we're cubing the dimensions, cubing the ratio, which would give us, let's see, the original tank was 2,000 cubic feet over x, which is the new tank, which we don't know. Well, 1/2 to the third power is 1/8 equals 2,000 divided by x. I cross multiply. And that gives me the new volume as 16,000 cubic feet, which would be answer D. Your vocab in this section would be similar solids.